Okay, in this video we will talk about dividing fractions, okay? Um, Dividing fractions is different than multiplication or addition or even subtraction of fractions. So I guess to get an understanding, we'll go back to our pi. So let's say I divided this into two parts. We know by our fractions that this both has to be 1/2 because 1/2 plus 1/2 is equal to 2 over 2 because you saw we have the same denominator, so you just add that. And when you find a common divider between these, it would be 2. So you know that this reduces to 1 over 1, which is equal to 1. So you know that this is a full pi, and by that, if I was to tell you something like 1/2 divided by 1/2, you would assume, yeah, that would have to be 1, right? Because if, let's say you have, because what I said in previous videos, some number divided by itself has to give you that identity of 1, because that's just one of the axioms of mathematics. So, 4 divided, that percent sign again, 4 divided by 4, that's equal to 1. The number divided by itself is 1. So, how would we do this? How would we justify this in dividing fractions? I mean, what would we do? Well, this is what we do. If we have 2 1/2 divided by 1/2, see, because, right, when you take a fraction, let's say you have 4 divided by 2, that's equal to 2, that's equal to 4 divided by 2, which is equal to 2. This is division. So the same idea here would happen too. 1/2 divided by 1/2, and I'll just write it. So this is equivalent to 1/2 divided by 1/2. Now, what would we have to do here? Well, we know we have to get 1 here, so for this to make sense to us. So what would happen? Well, I'll tell you what happens. When you divide a fraction by a fraction, what you do is you look at, the only thing you have to change is this bottom fraction down here. So you just rewrite the first fraction. And this is why I had to teach you multiplication of fractions before I taught you division of fractions. So you times, and then you take this and you switch the denominator and numerator. So you would get 2 over 1. Right? So all you did here, you rewrote the first one, and now you switched the second one and just multiplied it by the first one. And what does this give us? Well, from our multiplication video, we learned that you just multiply the numerators, so 1 times 2, which is 2, and then you multiply the numerators, which is 2. And this is in its simplest form. So they both have a common denominator 2, so you know that this goes to 1 to 1, which is equal to 1. And that's what we told ourselves, that identity has to maintain that a number divided by its number is equal to 1. So all you do here is you write your first number and you multiply it by your second fraction with the denominator and numerator switched around. Now, let's do other examples here. So let me take something like 1/25, and let's say I divided it by, let's say I divided it by 1 over 25th. 1 over 25th. So what did we say we had to do? So 1 over 25 times 25 over 1. Well, we write this 25 over 25. Well, they share the same thing. 5 over 5, which is equal to 1. So, I use the same example again, but I really have to drive this home because this is a very important idea in mathematics to get this identity that a number divided by itself will give you 1. That is a very important identity in mathematics. Now let's do a different example. Let's say 1 over 100 divided by, let's say, 2/4. Okay? So, what is this equal to? Well, we write the first one, 1 over 100th, and we multiply it by the fraction here with the denominator and numerator switched around. So, what do we get here? Well, 4 times 1 is 4. 2 times 100 is 200. Well, we're not in simplest form yet, so this is another good time to show you. The greatest factor these two share together is 4, but let's start with 2. So 4 divided by 2 will give you 2, and then 2 divided by, well, 200 divided by 2 is 100. Well, this isn't in its simplest form either, so let's do 2 again. We know that this would be 1/50th, and see if we did 4, if we chose our original divisor to be 4, well, we would have got right here in one step. So even if you don't choose the greatest common factor between them, you'll still get to the same spot. So now let's see how this changes. So, let's say you have negative 50ths over 20ths over negative 20, negative 4 over 5. So, right, the same concept holds true. We take negative 50 over 20 and we multiply it by negative 5 over 4. So what happens here? Again, you just multiply across the numerators. You have 2 negatives, so it's just like taking the positive multiplication of them. 5 times 50 is 250, and 20 times 4 is 80. Well, these guys share a common denominator, and that common denominator would be 5, but for here, let's just start out with 2 just to see what happens. So if we go here, we know that if we divide negative 250 by 2, we'll have negative 125, and we know that if we divide 80 by 2, we'll get 40. Well, let's go again. Let's now divide this by 5. So negative 125 divided by 5, that's equivalent to 25. And then let's divide 40 by 5, which is 8. So look at that. We looks like, oh no, I was actually wrong. Actually, the greatest common factor is 10. So that and I should have saw that, but yeah, but we started out and we started with we started with 2, and we still got to the same spot as if by keep on reducing it. So that will finish the division. Next, I think I'll talk about decimals. Decimals seems like a very good way, and how you can write decimals, and how you can convert from decimals to fractions and from fractions to decimals. Okay. Like this video and comment it, and if you like what you see here, show it to other people. Thanks.